Around 12,900 years ago, the world was in the middle of something that looked very much like a recovery. The great ice sheets that had smothered much of the northern hemisphere for tens of thousands of years were retreating steadily northward. The climate had been warming for roughly 2,000 years by that point. Glaciers that had once pushed down into what is now Central Europe were pulling back, exposing bare rock and soil that vegetation quickly moved to colonize. Average temperatures across the northern hemisphere had risen significantly from their glacial maximum lows. The landscape of Europe and the Near East was transforming from open tundra into something considerably more hospitable: forests, grasslands, expanding wetlands that could support a much wider diversity of animal life and, by extension, the human populations that depended on hunting and foraging to survive. Human groups across the Near East and parts of Europe were doing considerably well in this warming world. Population densities, while still low by any modern standard, were growing in regions where food resources had become more abundant and reliable. In the Fertile Crescent, the arc of land stretching from the eastern Mediterranean coast through what is now northern Syria, southern Turkey, into the Zagros Mountains of modern Iran and Iraq, a particularly notable group of people had begun making choices that look, in retrospect, like the early stirrings of something much larger. These were the Natufians, a hunter-gatherer culture that had emerged in the Levant and had begun, by around 13,000 years ago, to establish semi-permanent settlements in places where wild cereals and game were plentiful enough to eliminate the need for constant seasonal movement. The Natufians are of particular interest to archaeologists studying this period because they occupy an unusual middle ground between purely nomadic foraging and the settled agricultural life that would emerge much later. They built stone-walled structures, ground wild grains using mortars and pestles that have been recovered from dozens of sites, kept dogs, buried their dead in cemeteries associated with specific locations, all behaviors that suggest a growing attachment to particular places in the landscape. Sites like Ain Malahar, in what is now northern Israel, show evidence of substantial permanent or semi-permanent habitation during this period. The Natufians weren't farmers in any strict sense, but they had begun organizing their lives around fixed locations and the harvesting of wild plant foods in ways that distinguished them sharply from more mobile hunter-gatherer groups elsewhere. Then, around 12,900 years ago, something changed. The warming trend that had been reshaping the world for 2 millennia reversed itself with a speed that is, by geological standards, almost instantaneous. Ice core records extracted from Greenland. That preserve a remarkably detailed chemical record of past atmospheric conditions, show that temperatures in Greenland dropped by somewhere between 10 and 15 degrees Celsius within what appears to have been a matter of decades, possibly less. To put that in perspective, that magnitude of cooling is roughly equivalent to the difference between today's climate and the depths of the last ice age, compressed into a time frame that would have fallen within a single human lifetime. This abrupt reversal of the warming trend is what geologists and paleoclimatologists now call the Younger Dryas. Named after a small flowering tundra plant, Dryas octopetala, whose pollen begins reappearing in European sediment records precisely at this boundary. The effects of the Younger Dryas were felt across a vast geographic area. In Europe, the forests and shrublands that had been advancing northward retreated. Tundra conditions returned across large portions of the continent. In the Near East, the woodland zones that the Natufians had been exploiting shrank considerably. The stands of wild wheat and barley that had supported denser Natufian populations became patchier and far less reliable. Across the North Atlantic region, sea surface temperatures dropped sharply, and glaciers began re-advancing in areas where they'd only recently begun to melt. The event lasted approximately 1,200 years, finally ending around 11,700 years ago, when global temperatures rebounded again, this time to broadly modern levels. During those 12 centuries, the world was substantially colder and drier across much of the northern hemisphere than it had been immediately before. The question of what caused the Younger Dryas has been a major subject of debate in the paleoclimate community for decades. No single explanation has achieved universal acceptance. The leading hypothesis for most of that time has centered on a massive pulse of fresh water released into the North Atlantic from a glacial lake called Lake Agassiz. That occupied a vast area across what is now central Canada. As the ice sheets melted, this enormous proglacial lake accumulated extraordinary volumes of fresh meltwater. The prevailing hypothesis holds that at some point this water was released catastrophically into the North Atlantic, perhaps through outlets connecting to the St. Lawrence River system or Hudson Bay. Fresh water is less dense than salt water. A sudden influx of that volume into the North Atlantic would have disrupted the Atlantic meridional overturning circulation, the system of ocean currents that transports warm water northward and plays a critical role in regulating European and North Atlantic climate. If the overturning circulation slowed dramatically or shut down entirely, it would have produced precisely the kind of rapid cooling captured in the Greenland ice cores. The freshwater pulse hypothesis is compelling and broadly consistent with the available evidence, but it's faced some complications, primarily because direct physical evidence of the specific drainage route for Lake Agassiz at exactly 12.900 years ago has proven difficult to confirm with certainty. A more controversial competing hypothesis, proposed in a 2007 paper and since the subject of considerable scientific dispute, suggests that a comet or asteroid fragment, or perhaps a swarm of smaller bolide fragments, struck or exploded over the North American ice sheet at the onset of the Younger Dryas, triggering widespread fires, a layer of dust and soot in the atmosphere, potentially destabilizing the ice sheet in ways that contributed to rapid cooling. Proponents of this bolide impact hypothesis point to a thin layer of materials including nanodiamonds, microspherules, elevated iridae, concentrations found at sites dating to the Younger Dryas boundary. Critics have challenged both the reliability of these markers and the interpretation of the data. The debate remains active in the scientific literature. A third, less prominent hypothesis involves volcanic forcing, the idea that one or more large eruptions contributed to the cooling, though this is generally considered insufficient on its own to account for the full magnitude of the temperature drop recorded in the ice cores. Whatever its cause, the effects of the Younger Dryas on human populations in the Fertile Crescent appear to have been significant. The archaeological record shows that many Natufian sites were abandoned during the cold period, particularly in areas that became too dry and cold to support the dense wild plant resources the culture depended on. Some populations appear to have retreated to refugia, smaller areas where conditions remained relatively favorable, while others became more mobile again, reverting to patterns of movement that the earlier warming period had made unnecessary. The cultural continuity that had been building in the Levant during the pre-Younger Dryas period was disrupted. The elaborate social structures associated with permanent Natufian sites seem to have contracted CC considerably. Sites like Ain Malahar show evidence of reduced occupation intensity during this period, suggesting that the populations using them shrank or spent far less time there than they had before. The relationship between the Younger Dryas and the subsequent emergence of agriculture is one of the more genuinely complex questions in the archaeology of this period. One intuitive reading of the evidence would suggest that the Younger Dryas simply set things back, that it interrupted a trajectory towards settled life and cultivation that was already underway among the Natufians, delaying the transition by roughly 1,000 years. There's real support for this interpretation in the abandonment of sites and the contraction of Natufian cultural networks during the Cold Period. But a number of archaeologists have argued for a more counterintuitive relationship, suggesting that the Younger Dryas may have actually created the conditions that eventually made agriculture not just possible but necessary. The logic of this argument runs roughly as follows. As the Younger Dryas made wild food resources less abundant and less predictable, the populations that survived in the Fertile Crescent were under increasing pressure to find ways to manipulate their food supply rather than simply harvesting whatever the landscape offered. In regions where refugia maintained some wild cereal populations, people may have begun more deliberately tending, protecting, eventually selecting from those plant populations in response to scarcity rather than abundance. In this reading, it wasn't the comfortable warmth of the early post-glacial period that drove the invention of farming, but the stress and resource unpredictability of the Younger Dryas itself, a kind of forced ingenuity born from difficult circumstances. The agricultural communities that appear clearly in the archaeological record after 11,700 years ago, in what's known as the pre-pottery Neolithic period, might in this sense be understood as a response to the Younger Dryas rather than a delayed continuation of trends that predated it. The evidence for this hypothesis is suggestive, but not conclusive. Genetic analyses of early domesticated wheat and barley strains have been used to try to trace where and when domestication first occurred, with results pointing to the Fertile Crescent broadly, but not resolving the finer chronological questions with any precision. The plant remains from sites dating to the Younger Dryas itself, and the transitional period immediately afterward are intensively studied. But distinguishing early cultivation from intensive foraging of wild plants is genuinely difficult in the archaeological record. Scholars working from the same data sometimes reach substantially different conclusions. There are sites in the northern Levant and southeastern Turkey, most notably Göbekli Tepe, the massive ritual complex in what is now southern Turkey that was constructed beginning around 11.600 years ago. That complicates simple narratives about the sequence and timing of events in this region considerably. What's reasonably well established is that by the time the Younger Dryas ended, around 11,700 years ago, the Fertile Crescent was the site of one of the most consequential transitions in human history. Agriculture emerged there, and from there it spread, eventually reshaping population densities, social organization, the long-term trajectory of human civilization across a substantial portion of the globe. The fact that this transition happened so soon after the close of a 1,200-year cold interruption, rather than smoothly following on from the Natufian semi-sedentary period that preceded it, is precisely what makes the causal question so difficult to resolve cleanly. Scholars working on this problem haven't arrived at anything like consensus. New excavation data and paleoclimate reconstructions continue to shift the conversation in ways that make firm conclusions premature. Whether the Younger Dryas delayed civilization by 1,000 years or quietly forced its hand is a question archaeologists are still trying to answer. If you want to explore this period in more depth, there are a few carefully selected books and research sources linked in the description that go further into the evidence behind it. In the span of roughly 50 years, somewhere around 1200 BC, nearly every major civilization in the Eastern Mediterranean either collapsed entirely or came close enough to it that historians still argue about the distinction. The Mycenaean palace centres of mainland Greece, Mycenae, Tiryns, Pylos, were burned and abandoned within a relatively narrow window of time. The Hittite Empire, which had contested Egypt for dominance over the Near East for more than a century, simply ceased to exist as a coherent state. The city of Ugarit, a thriving commercial hub on the Syrian coast and one of the most cosmopolitan settlements of its age, was destroyed and never rebuilt. The Kassite dynasty that had ruled Babylon for roughly 4 centuries collapsed around the same period. Even Egypt, which survived, was so severely weakened by the end of the 12th century BC that it effectively withdrew from its territories in Canaan and spent the following centuries in a condition of substantially diminished power. To understand the scale of what was lost, It helps to understand what the late Bronze Age world actually looked like in the centuries before the collapse. By roughly 1400 BC, the Eastern Mediterranean had developed into something that a modern economist might recognize as a globalized system, though that word carries connotations the ancient world would not have used. Palace economies centered in Mycenae, Hattusa, Ugarit, Babylon, and Egypt were not merely trading with one another. They were functionally dependent on one another in ways that made each civilization vulnerable to disruptions occurring hundreds of miles away. Copper came primarily from Cyprus, and without it, bronze production across the entire region would have been impossible. Tin, which had to be alloyed with copper to produce usable bronze, traveled even farther, originating from sources in what is now Afghanistan and possibly Central Asia, moving through a chain of intermediary traders before arriving at workshops in Greece or Anatolia. Grain moved in large quantities from Egypt into regions that could not reliably feed their own populations through local agriculture alone. Luxury goods, ivory, glass, ostrich eggs, fine textiles, elaborately worked gold objects, passed between royal courts in diplomatic shipments that were as much about signaling political relationships as they were about material exchange. The palace administrators who managed these networks kept meticulous written records. In Mycenaean Greece, the Linear B script, an early form of Greek adapted from an earlier Aegean writing system, was used almost exclusively for bureaucratic accounting, tallying livestock, recording grain allocations, tracking the movement of bronze ingots and finished weapons. These were not literary or religious texts in most cases. They were the operating records of a complex redistributive economy, and their survival gives historians an unusually detailed picture of how tightly managed these systems were. Similar administrative structures operated from Egypt to Mesopotamia, and the diplomatic correspondence that passed between rulers across this entire zone suggests a level of political sophistication that would not reappear in the region for many centuries. Then, within the span of roughly 2 generations, most of it was gone. The destruction layers at sites across Greece, Anatolia, and the Levant tell a consistent story across many excavations. Buildings burned, populations displaced or drastically reduced, and in many cases, sites simply abandoned without any subsequent evidence of rebuilding or reoccupation. Pylos, the Mycenaean palace, whose clay tablet archives happen to be among the best preserved examples of Linear B writing ever found, appears to have burned around 1180 BC. The Linear B script itself disappeared along with the palace system that had generated and depended upon it, and Greece entered a period of several centuries during which there is no evidence of any writing at all. At Hattusa, the Hittite capital in central Anatolia, the destruction was thorough and final. The site was never reoccupied as a significant urban centre. And at Ugarit, archaeologists found something that has since become one of the most widely cited images of the collapse as a whole: clay tablets still sitting in a kiln, mid-firing, at the moment the city was attacked. The Egyptian records from this period contain repeated references to a group the pharaohs called the Sea Peoples, a loose and apparently diverse confederation of migrants or raiders who appear to have swept southward through Anatolia and the Levant in successive waves during the reigns of Ramesses III and his predecessors. Egyptian reliefs carved at Medinet Habu depict these groups in naval engagements and large-scale land battles, and the accompanying inscriptions describe them as having destroyed multiple major kingdoms before pressing toward Egypt itself. Ramesses III claimed to have repelled them in a series of engagements, though the evident weakening of Egypt in the decades that followed suggests that whatever victory was achieved came at considerable cost. The Sea Peoples hypothesis held considerable traction through much of the 19th and early 20th centuries, offering a narratively clear explanation for a set of destructions that otherwise seemed puzzlingly simultaneous. A wave of external invaders, the argument went, had dismantled a series of civilizations that proved unable to defend themselves. More recent scholarship has moved substantially away from that framing, however, and toward a view in which the sea peoples were more likely migrants already displaced by a broader breakdown, arriving in regions whose political and economic systems were already under severe stress. If major Hittite sites were showing signs of abandonment before the sea peoples could plausibly have reached them, and if internal instability was already fracturing palace economies from within, the picture becomes considerably more complicated than an invasion narrative can account for on its own. Paleoclimatological evidence gathered over the past 2 decades has added a significant dimension to the ongoing debate. Pollen records extracted from lake sediments in Cyprus, Turkey, and the Levant show a pronounced decline in arboreal vegetation, consistent with prolonged drought conditions beginning in the early 12th century BC, precisely the period when the palace systems were entering their terminal phase. Isotope analysis of sediment cores from sites including the Sea of Galilee and several lakes in Cyprus has pointed toward a multi-decadal drought, reducing agricultural output across the eastern Mediterranean during this window. If grain production across Egypt and the Levant declined substantially over even a decade or two, the redistributive network that held palace economies together would have come under simultaneous and compounding pressure almost everywhere it operated. Regions that depended on Egyptian grain imports would have faced shortfalls they had no domestic capacity to offset. Rulers who could no longer reliably feed their administrative classes, their craft specialists, or their standing armies would have confronted internal unrest with resources already diminished. The palace systems that managed late Bronze Age economies were architecturally dependent on surplus. They required stable and predictable agricultural production to sustain the bureaucracies, artisan workshops, and military establishments that defined them. Remove the surplus, and the structure becomes unstable in ways that no single corrective measure could address. Eric Klein, whose 2014 synthesis of the current scholarship on the subject argued at length against monocausal explanations, framed the collapse as a cascading systems failure in which multiple stresses arrived simultaneously on a network that was inherently vulnerable because of its very interconnectedness. Drought, internal rebellions, disrupted trade networks, the loss of access to critical raw materials including tin, and the movements of displaced populations were all, in Klein's reading, components of a single catastrophic failure rather than sequential causes and effects. No single node in the system failed first in a way that unambiguously triggered all the others. Instead, multiple failures appear to have amplified one another until the entire network crossed a threshold from which recovery was not possible. The tin supply problem is worth examining on its own terms, because it illustrates how a single material could carry consequences far out of proportion to its apparent significance. Bronze production required tin in approximately a 1:9 ratio with copper, and the sources of tin accessible to the ancient world were geographically remote from the primary centers of bronze consumption and fabrication. The trade routes that carried tin from Central Asia to workshops in Greece and Anatolia were among the longest and most logistically complex supply chains in the Bronze Age system, passing through multiple intermediary regions and dependent on political stability across an enormous geographic range. If those routes were interrupted, whether by drought affecting populations along the way, by political instability in intermediary kingdoms, or by any combination of those factors, the effect would have propagated outward almost immediately. Without tin, bronze production stopped. Without bronze, the weapons, agricultural tools, and prestige objects that palace economies relied upon for both internal redistribution and external trade could not be manufactured at scale, and the entire economic logic of the palace system lost its material foundation. The aftermath was severe across most of the affected region. Population estimates for Greece, Anatolia, and the Levant suggest marked declines through the 12th and 11th centuries BC, with some areas apparently losing the majority of their settled population within a few generations. The sophisticated administrative systems of the late Bronze Age vanished, and with them, the literacy those systems had sustained. The archaeological record, from what historians conventionally call the Greek Dark Ages, spanning roughly 1100 to 800 BC, shows dramatically simplified material culture across the affected zones. Fewer large settlements, sharply reduced evidence of long-distance trade, much less craft specialization, and the near-total disappearance of monumental construction. What emerged from that period of contraction, however, included several developments that would eventually prove more widely consequential than what had preceded them. Iron metallurgy, which had existed on a limited scale during the Late Bronze Age, expanded substantially after the collapse. Partly because the disruption to tin supplies made bronze production unreliable across much of the region, and partly because iron ore was geographically far more accessible than either copper or tin had been. The spread of iron tools and weapons gradually transformed agricultural capacity, construction methods, and the conduct of warfare in ways that bronze had never quite achieved at scale. Alphabetic writing systems, developed and disseminated by Phoenician traders who weathered the collapse, consider, ably better than most of their neighbors, began spreading across the Mediterranean during the early first millennium BC, and ultimately provided the template from which Greek, Latin, and their many descendants descended. Whether those developments would have emerged as quickly within a functioning Late Bronze Age palace system remains genuinely uncertain, and the question is probably unanswerable. The collapse created conditions in which older structures could not simply reassert themselves, and what grew into that space turned out to carry fewer of the systemic fragilities that had defined what came before. The unresolved questions are substantial enough that the Bronze Age collapse continues to attract active scholarly attention rather than settling into a fixed consensus. What the available evidence does seem to support, taken in its entirety, is that the late Bronze Age world had constructed a level of systemic interdependence that left it with very limited capacity to absorb multiple simultaneous shocks, and that when those shocks arrived, the failure was as total as the integration had been. The very sophistication that made the late Bronze Age world so impressive may have been exactly what made it so catastrophically fragile. For those interested in looking deeper into how these systems actually functioned, there are additional resources linked below that break down the evidence in much greater detail. At the peak of the last ice age, about 20,000 years ago, the map of the world looked nothing like what we'd recognize today. The continents themselves were in roughly the same positions, but the coastlines were entirely different, and vast stretches of land that are now permanently submerged beneath shallow seas were then open terrain, inhabited by animals and, in many places, by people. Sea levels stood approximately 120 meters lower than they do at present, a difference that exposed enormous continental shelves across every ocean basin on Earth. The scale of this is difficult to fully appreciate without looking at a map and tracing where the coastlines would have actually been during that period. Britain wasn't an island at the last glacial maximum. It was connected to continental Europe by a broad lowland region, now submerged beneath the southern North Sea, that geologists and archaeologists have named Doggerland. This wasn't a narrow land bridge or a barely habitable corridor of frozen ground. It was a substantial landmass stretching across what is now hundreds of kilometers of open water, with rivers, wetlands, forests, and the kind of diverse ecological productivity that would have attracted human settlement. Similarly, the Persian Gulf as we know it today simply didn't exist. In its place was a river valley fed by the Tigris, Euphrates, and several other watercourses, draining southward into the Indian Ocean through a relatively narrow outlet. Across Southeast Asia, the Indonesian archipelago wasn't yet fragmented into the thousands of islands it comprises today. The landmass that geographers refer to as Sundaland connected what are now Sumatra, Java, Borneo, and the Malay Peninsula into a single continuous territory roughly the size of India. And on the other side of the Pacific, a land bridge spanning what is now the Bering Strait, linked Asia to North America, a connection through which the ancestors of all indigenous American populations are widely thought to have migrated. The process by which all of this land was eventually lost to the rising sea wasn't a smooth or even gradual transition. The ice sheets that had locked enormous volumes of fresh water out of circulation for tens of thousands of years didn't simply melt at a steady rate. Instead, the deglaciation was episodic, punctuated by periods of relative stability and then sudden dramatic surges. The most significant of these episodes is known as Meltwater Pulse 1A, which occurred approximately 14,000 years ago and represents one of the most rapid sea level rise events that researchers have been able to document in the geological record. During this pulse, sea levels are estimated to have risen by somewhere between 16 and 25 meters over a period of just a few centuries, a rate of rise so extraordinary that it would have been perceptible within a single human lifetime, possibly within a single generation. The precise source of the meltwater responsible for this pulse remains debated, with researchers pointing to potential contributions from the North American Laurentide ice sheet, the Antarctic ice sheet, or some combination of both. What isn't debated is that the consequences for anyone living along a coastline during that interval would have been severe and irreversible. Doggerland offers perhaps the most thoroughly studied example of what this process meant for inhabited landscapes. Archaeological work in the southern North Sea, which has accelerated considerably over the last 2 decades, largely because of material dredged up by commercial fishing operations and offshore energy development, has recovered stone tools, animal bones, and organic material from what was clearly a rich and productive environment. The region supported woolly mammoths, aurochs, red deer, and a wide range of other large fauna, all of which would have made it highly attractive to the hunter-gatherer populations of northwestern Europe. A catastrophic final inundation of Doggerland may have been hastened by a massive submarine landslide off the Norwegian coast known as the Storegga Slide, which occurred around 8,200 years ago and would have generated a tsunami, sweeping across any remaining low-lying ground in the area. By roughly 6,500 years ago, Britain had become an island, and the connection to mainland Europe had been severed permanently. The transformation of the Persian Gulf basin unfolded over a broadly similar timeframe, though the details differ. At the last glacial maximum, the basin was a river valley sitting well above sea level, and based on the ecological conditions of the region, it would have offered fresh water, vegetation, and game to human populations, at a time when much of the surrounding landscape was considerably more arid. As sea levels rose, the Indian Ocean began flooding the basin from its southern end, progressively inundating the valley over a period of several thousand years. By approximately 6,000 years ago, the Persian Gulf had reached something close to its present configuration. Some researchers have speculated that this flooding of a previously habitable and potentially densely settled riversoi stem may be connected to the cultural memory preserved in the flood traditions of Mesopotamian civilizations, though the link remains speculative and is treated cautiously by most scholars in the field. The Black Sea presents yet another regional case that has attracted significant scholarly attention. The prevailing theory, associated most prominently with geologists William Ryan and Walter Pittman, holds that the Black Sea was once a freshwater lake sitting at a level considerably lower than the Mediterranean, and that around 7,600 years ago, rising Mediterranean waters breached a natural barrier at what is now the Bosphorus, and flooded the basin catastrophically. The model is disputed, and subsequent research has complicated the picture, with some studies suggesting the connection between the Mediterranean and the Black Sea was more gradual, or that it occurred earlier than Ryan and Pittman proposed. What the evidence does support is that the Black Sea basin underwent a significant transformation as global sea levels rose, and that populated areas along its former shorelines are now submerged. The central problem that all of this creates for archaeologists and historians is a fundamental one. The people who lived along these coastlines during the late Pleistocene and early Holocene weren't living in the interior highlands that have since been studied extensively. They were living on the coast, where resources were abundant, where rivers met the sea, where shellfish, fish, and marine mammals supplemented terrestrial food sources. And those sites are gone, not destroyed in any above-ground sense, but submerged under meters of water and centuries of accumulated sediment. The archaeological record we have for early human behavior and settlement during this period is therefore systematically biased toward inland and upland environments, simply because those are the environments where the sites have survived. We may be working from what is, in effect, a heavily incomplete sample of where people actually were. This isn't merely a theoretical concern. The few underwater archaeological sites that have been investigated in detail have repeatedly demonstrated that significant human activity occurred in locations now well below sea level. Submerged sites off the coast of India have yielded evidence of habitation extending back several thousand years before those areas were flooded. Work in the Mediterranean has identified sunken harbours and settlements along coastlines that have subsided over time. Off the coast of Florida, submerged sinkholes have produced human remains and artifacts dating to the early Holocene. Each of these finds represents a fraction of what likely exists, constrained by the enormous logistical difficulty of conducting systematic archaeological survey in open water. The question of flood myths is one that researchers approach with varying degrees of caution, and it's worth being precise about what the evidence does and doesn't show. Stories describing a catastrophic inundation of land by water appear in the traditions of dozens of independent cultures across the globe. In Mesopotamian texts predating the Hebrew Bible by centuries, in Greek mythology, in Hindu scripture, in the oral traditions of indigenous Australian peoples, in the folklore of communities along the coast of the Pacific Northwest, and in numerous other contexts. The instinct to read all of these as reflections of a single historical event is almost certainly wrong. But the instinct to dismiss them entirely as purely mythological inventions with no referential basis may also be an over-error correction. The flooding that accompanied the end of the Ice Age was real, it was dramatic, and in some areas it unfolded rapidly enough to be witnessed by people alive at the time. Whether communities could preserve a coherent memory of coastal flooding across the many generations separating those events from the earliest written or recorded traditions is a question that researchers in cultural memory and oral history continue to debate without arriving at any firm consensus. Underwater archaeology as a discipline is still in relatively early stages of development compared to its terrestrial counterpart. The technology required to conduct systematic survey of the seafloor, to identify and excavate sites in deep water, and to recover and conserve organic materials from submerged environments has advanced significantly over the last 2 decades. But the resources devoted to this work remain limited relative to the scale of what may be out there. Surveys conducted using side-scan sonar and sub-bottom profiling have identified what appear to be structural features and landscape modifications in several submerged areas. But detailed investigation of most of these locations hasn't yet been carried out. What this means in practical terms is that the current understanding of early human migration, coastal settlement, and the development of pre-agricultural societies rests on evidence that may be fundamentally skewed by the accidents of preservation, the routes by which people moved across Sunderland, the nature of communities that may have clustered around the Persian Gulf River system, the population and cultural complexity of Doggerland. All of these remain poorly understood, and the most direct evidence for answering questions about them is sitting on the seafloor, in many cases under conditions that make recovery extremely difficult. Some of the most important chapters in early human history may be sitting on the seafloor, and we've barely begun looking. If you're drawn to questions like this, you'll find a curated selection of deeper reading and research in the description that explores many of these submerged histories in more detail.